fructose 6-phosphate. Let's take this molecule and add one more phosphate, this time at carbon 1. Okay, so we use another ATP. And we end up with fructose 1,6-bisphosphate. So here's carbon 1 here. And notice that this is just drawn in a different animer. Okay. Now, fructose bisphosphate has this cyclic structure. Let's redraw this cyclic structure in the open chain form. Keep in mind that hemiacetals are not very stable, so they always revert back and forth to their open chain forms. Okay, so here's fructose here. There's a phosphate on 1, phosphate on 6. Now, at this stage, we have a 6-carbon sugar. But like this here, the 6, we got to make 2 3-carbon sugars. So wait, we got to take this molecule and chop it in half. Okay? It's going to go from 6 to 2 3s. So that is a very, very important reaction here. You got to take a 6 and just chop it right in half. Now, you've got to think about the reactions that break carbon-carbon bonds. One reaction that we had looked at was the so-called retroaldol reaction, the reverse of the forward aldol. We'll look at the mechanism in a bit, but you can appreciate that if you're to chop this right in half, the bond that you'll have to break is the one right there. And the bond here is between the alpha carbon and the beta carbon. Okay? There's the carbonyl, the neighboring one's alpha, the one down the road is beta. So we do have retroaldol reaction. There's the top half, there's the bottom half. Now if we compare these two structures, they're just isomers of each other. This is a ketose, this is an aldose. So these two are interconvertible by an isomerization reaction. It's another isomerization here. So we make the top and the bottom. The top could isomerize to the bottom and vice versa. So after these steps, we've got glyceraldehyde 3-phosphate. If we took the dihydroxyacetone and isomerized it to glyceraldehyde 3-phosphate, what we would get would be every mole of glucose, 2 moles of this material. So in this energy requiring phase of glycolysis, we put in a total of 2 ATPs, one here and one here, 1 mole of glucose, and we spit out 2 moles of glyceraldehyde and phosphate. So it took us some energy to get there. Now, let's go on to what we call the energy production phase of glycolysis.